Welcome to this XA 2021 talk. In this talk, we're going to discuss how to measure the pros and cons of using software dependencies with a novel metric, technical leverage. It measures dependencies and yet talks about exposure, risks, and security. This research was partly funded by the Horizon 2020 Azure Moss project. Let's start discussing how software development changed. We are taught to see software as a large animal, controlled by its developers. After all, it's their own code. If a security vulnerability is found, they can go and fix it. But this is no longer true. Now developers use free open source software as building blocks. In this way, they can focus on their own added value functionality and rely on other people's code for everything else. Homegrown code may be only 5%, and dependency code is 4 times bigger than own code. Developers are not actually writing a big homegrown control animal. They're balancing on a pyramid of many shifting rabbits, software dependencies. Yet, code coming from dependencies is still code. It can have bugs and security vulnerabilities. You have to wait for a fix coming from upstream developers and must update to the new version, lock, stock, and barrel. Its new functionality, which you may not need, may introduce breaking changes. If there are serious vulnerabilities in the dependencies and you decided not to update it, you may end up in the evening news. We need to have an indicator to understand our exposure. And here we can learn something from finance. 30 years ago, in a landmark paper in the communication of the ACM, Eric Allman popularized the notion of technical debt, first introduced by Cunningham 30 years ago. Shipping first-time code is like going into debt. This is a very active research area, and everybody agrees that technical debt describes unfixed issues accruing in one's own code. But now, internal own code is 5%. What about the rest? How do we account for dependencies? Enter technical leverage. So, own code is the part you developed. Dependencies, both direct and transitive, are other people's code that you reuse, but they control. In finance, people borrow money to multiply the effect of their own assets. Leverage is the ratio between debt and equity. Other people's money versus your own money. Applied to software, technical leverage is the ratio between other people's code, software dependencies, and your own code. In finance, leverage multiplies income, but it multiplies losses as well. The same holds for software. Leverage allows developers to develop their project faster and focus only on the distinguished functionality. However, it increases the size of the uncontrolled software code used by the project. It increases the risk of having a security vulnerability. Do you remember Lehman Brothers? They leveraged 30 to 1. At some point, even 60 to 1. What about Software Brothers?
Let's see some real-world software projects. We selected the 200 most popular FOSS Java libraries used by a multinational software development company and its customers or internal production level software. This resulted in more than 8,000 distinct library versions, or GAVs in Maven terminology. For simplicity, we focus only on the leverage on direct dependencies. Every point in this scatter plot is a software library. On the x-axis, we have the library own size, the homegrown code of a library. On the y-axis, it's technical leverage. Both axes have logarithmic scale. Consider the Network Application Framework library io.netc It has more than 175,000 lines of own code. Another example, Java Spring Framework. This is a pretty big as well. around 500,000 lines of code in total. But what about its own code? 200,000, 100,000, 10,000, 1,000? In fact, around 1,000 lines of code. Wait, but how is it possible? The org Spring framework, Spring Aspects library, have a leverage of more than 400. Which means that for every line written by its developers, there are 400 lines written by somebody else. Ionity all is smaller, but not that small. It has leverage of 7. We clearly see the relation between direct leverage and own code size. The bigger the library, the smaller the technical leverage. The median technical leverage reduces from 15 for libraries with small-medium code base to 0.5 for libraries which have a big own code base. So, libraries with a small code base stands on a very large number of pygmies. They have a great leverage. Or in other words, they ship other people's code. Leverages multiply profits. So you ship a functionality for 1.5 million lines of code, but you only write 150,000 lines. This is a great business opportunity, isn't it? But do you remember Lehman Brothers? Here we have the vulnerabilities present in the library on the x-axis, and on the y-axis the distribution of the leverage of libraries having that number of vulnerabilities. A pattern is clear. As leverage increases, so does the number of vulnerabilities. There are some exceptions on the very right of the plot. Some libraries with a high number of vulnerabilities have a relatively small leverage. They have a high number of vulnerabilities just because they are big. If you have more than 100,000 of lines of code, a paltry leverage of 4 means shipping more than 500,000 lines of code. So, if you want to heavily leverage on others' code, you have to accept a higher security risk. To recap, technical leverage is a simple yet effective metric to understand your exposure to dependencies in your software projects. For libraries in our sample with a small-medium own code base, usage of dependencies pays off. Leverage and ship more than 4 times your own code. You'll need just 2 extra days for each release on average. But the same 4-fold increase in the total code size of a library means 60% increase of a chance to have a vulnerability in your library. Maybe in your code, maybe in somebody else's code. If you're interested in the idea of technical leverage, please visit the techleverage.eu website. The website allows you to check technical leverage for some Java libraries in the live demo section. Find related publications, empirical dependency studies, or introductory magazine papers, blog posts about software dependencies. Thank you for your attention.